Boom. So thank you for joining us today. And we are not going to talk totally about privacy, but if it would be interesting for you, we'll join and jump also to those topics because it's really, really important. But our way is actually that we would like to show you also with some real life examples how to integrate your own data into the existing models. It can be ChatGPT, it can be basically anything, but how to make them better and actually understand what you need in your local organizational context. So today you will spend this half an hour with me. I'm Vojcik. I have experiences with product development and like taking care not only about the IT side, but also the business part. And with me is Filip, which is 9+ years already in AI topic and AI zone. If we can, Filip, they say something about you.
Yeah. So it's 9 years of face recognition and document analysis, and now it's to the LLMs where the industry takes us, right?
Yes. So I would like to, we will tell you a little bit about us, like what we do as a company. We will be very short. So if you can in the time, at least open the Slido. We have there like 4 questions just for you, which will help us actually to make presentation better. We want to understand how much you already know about LLMs and what are your experiences with it. And I will come back to the results of the polls as soon as we do this short intro. So we are from company Ablenio. We are here in Slovakia, Bratislava-based software house. We do a lot of stuff in 4 countries, not only data and AI, but a lot of development in the application area. It's almost 80 of us, and we are still expanding mainly in the US and here in Slovakia. What we do, we really are not just that small. We work with a lot of major players, banking, telco, etc. So now what we are doing here, we are really starting our own product, and it's focusing on enriching the ChatGPT or other models with their own data. And we will tell you how. So those questions. First one was like, do you know what is LLM? And we asked this question because a lot of people is always saying the use words buzzword like AI. But actually, majority of the activities here are large language models. And a lot of people are getting confused with it. So I see we have good publicum. If we can go to second question. We were asking like, okay, have you already tried to fine tune it or to train it by yourself? So Filip, we have a good audience because almost half of the publicum, or at least those who voted, they already try to enrich the data.
Awesome.
So we are looking forward on your questions. Please be also specific when we will be asking like how to do or what not to do, etc. If we can go to another one. Yes, so are you using models? Yes, no. Okay, super. So 2/3 of the people already here use the models. I will show you one of the study which was actually done to compare how can you improve yourself when you are using this type of LLM models, not only for development or also in your day-to-day business life. So it will be on the next slide. And if we can move to the last one. Okay, so also 2/3 of people try to enrich it already with their own data. So good, those were those questions, what we were talking about. And what I told you, like one of the researchers, we can share with you later the link, already found out and did it also in some technical study really to measure it. That if you are using these LLM models to help you generate a response, proofread the text, use it for inspiration, or if you are coder, use it even for coding, it can really help you significantly like to boost your performance outcomes. So basically those people who are using actively these models and know how to do prompt engineering, know how to ask, and actually are using it for creation of their context can get significant better results like those who are doing it just with their brains. So basically, if you are not using it yet, it's a good way to start because it will be hard to compete with people who will use it to get their results. And if you do it just by yourself, it's really more complicated. And this one is applicable also to business world, like the companies or the institutions which are focusing mainly on the human power. Can be lacking in the performance and especially in the productivity. Because if you are using these models in the right way, you can really boost your productivity and get to the results faster and with higher stability. So what we will do now, that we start our presentation, like if you would like to enrich your data, first, before you even start, you should think about at least these first 3 concepts to really choose correctly and rightly how to do it, because there are a lot of approaches. So we will start with a little bit of theory, what to think about when you are thinking to really train your own model or to enrich existing chat models or ChatGPT models or whatever. So Filip, please.
Sure. Thank you. So question number 1, would you embed your data or fine-tune your models? What does it mean? So if you embed your data, you represent the sections of your data as a multi-dimensional vectors, which means each section, sentence, paragraph, something, it's up to you. You will represent it as a vector that consists, in this case, of more than 1,000 numbers. And these numbers represent the meaning, and they also represent how close your sentence is to a different sentence. As you can see on the left side, it is kind of simplified because it's only 2D space, but you can see that the sentence of sort like a sad boy is walking and a little boy is walking are very close to each other because their meaning is almost similar, while something totally different, like on the right bottom side, like there is a dog running past the field, is much more further from that space. So this is a vector representation that really helps you to get your knowledge base. In this case, it might be some guidelines of a company like a bank or something similar, and you can take this data and represent it in such a way. So this is one way. Another way, and it's very debatable which one to use, and this will be another question for Slido, so get ready for that, is whether you will fine-tune your model. So fine-tuning means you will take a piece of your model, it's a machine learning model I'm talking about with multiple layers, and you will detach a layer and change it based on your new data. And there are also benefits to doing that. In our case, I can say upfront, for our case, we chose a vector embedding, but we can move to the question itself.
Yeah, I see that we have there by mistake yes, no. So let's say that the yes is embedding. Are we already there? Oh no, okay, good. So we have it in correct way. If you can show it back. So embedding or fine tuning, and there is actually no correct answer like this or that. It depends on based on your use case. Because in case that you are not going to refresh your data on daily basis or hour basis or minute basis, then it's okay also to do it for fine-tuning. Like we were just discussing with Filip, there was a case with the test cases. So if you would like to do this, your use case is to generate the test case, then it's good to fine-tune your model in a way that you understand how the test case should look like, what should be the structure, and you can have it fixed in your model, like really like retraining it totally. But if you are teaching new data about products on your eShop or about your processes or general conditions, which are changing on regular basis, in that way it's more flexible if we use embedding one, like not to have it so fixed, so we don't have to fine-tune it each time there is a data update or anything. So it depends on the usage or what would use.
Absolutely, that's it.
Yeah.
Also, privacy can be a thing because when you're fine-tuning, you're exposing all your data at once to the model. So if you're fine-tuning something like GPT, it all goes there at once. With embeddings, it's sort of different, but it's still there in a way.
Yeah. Okay.
Do we have some answers?
Yes, basically it's 50-50.
It's 50-50.
Yeah, 55 is for embedding and that's strange. 53 is for fine-tuning. So maybe they are also using some large language model which is not very good in calculations to 100. But so it seems like very equal. So really, it is no one winner. It depends on the situation where you want to use it. We will touch like which one we choose. As Filip already mentioned, since that part what we are doing is that we are trying to teach the model the data on regular basis, which are basically changing. Just take like as an example the eShop. eShop still has new products and new product definitions and descriptions. So we need to refresh those parts regularly, and we also want to have it under control, like the selection process, and to make sure that it's repetitive. So we went with embedding, but it really depends on the case.
Okay, let's move on. Next thing, it's very important. Always, it's all about data, and both quality and quantity matters. Each time you're facing a challenge in the space of machine learning, it's all about data. You can have whatever algorithms you want, but if your data is dirty, then you are not gonna get to the goal. So with this kind of data, we are facing, as I said, it's guidelines, it's PDFs, it's Excel files, it's websites, for example. The issues we are facing are structural, so I can say like sentence and paragraph structure is not maintained. For example, in PDF, if you have a sentence, but it is chopped and the part of the sentence is in the next line, it means it is already represented as two separate sentences, basically. And that might be an issue. Another thing, headers and footers, they repeat all the time. They can get merged with the previous text, and they can basically also break the knowledge. And table structure, we will show an example why it can be an issue. So these are like structural with the documents during the parsing process. You can also have issues with the text itself, informational duplicities, ambiguity in the information, some sort of biases, and domain-specific language. All these can be issues, and it's kind of good to have an approach to pre-process them and get rid of them. So the main takeaway is the data influences the approach that will be used later for the implementation. And that's also the answer to the previous question about whether to go for embeddings or fine-tuning. So next question is, what is the trickiest format to work with? And of course, there is not a single correct answer.
And this will be tricky also for Slido because it's open text. So we'll see if we will be matching it together. Or you can scream also from the audience. Like, what do you think is the trickiest one? Oh, we have some answers. Okay. PDF, image, audio, PPT, table, HTML, DWH, free text. So we can start like at least just choose some of those.
Yeah, there is a bit of truth to everything. WTF, definitely. I think there are such files in World of Warcraft, but that's not the topic here, I believe. Some of you may know. In our cases, the trickiest ones are PDFs and websites. It's really hard to scrape a website. All of them have different formatting, and PDFs, it's an issue on their own. Structural issues, especially images, I mean, you need to OCR them. There will be huge garbage to garbage prediction, so in the end you will end up with something that you did not throw.
Yeah, so for sure, images, PDF, those are at least those tricky ones, and the video first at least. Depends what you want to do with the video. At least first you have to convert it to some text if there is a voice. If you would like to understand the image, that's separate discipline, yes.
Yeah, and I will think of the WTF. Yes, that's something I will process. Yes. Okay, next one. If you want to get started, we already had a workshop yesterday. It was at 3:30. You can still see the content of the workshop at github.com/ableneo. It will be there. What you need, what are the technologies that are really good to initiate your stint with LLMs is have a framework like LangChain or something else. It's great for, it's a Python framework basically, and it allows you to interact with the models. It allows you to chain the models together, to query outside agents for new information like what is the current weather or stuff like that. So that's surely a good one for experimentation. Next one is good data parsing libraries. As I said, web scrapers, file readers like Pyramid PDF. I love it. I use it for a couple of years already. You need to have an NLP library to help you process the data, like Spacey, NLTK. You need to understand statistics and evaluation metrics because you need to know how good your model is. And that's the case all the time. It's really, really hard to say whether you are good enough. You can pick your cherries and show them to other people and you can feel great about what you have. But it's the evaluation as objective as possible that will tell you. And last but not least, it's Python, what you need. Okay.
So now we will tell you a little bit about our approach. So basically, we really went for that embedding part. So we are not fine-tuning the model, which is on the back. Like the application, what we built is actually consisting of 3 parts. Like one is presentation layer, which is like this interface on your left side. That can be simple web via which you are chatting, or it can be integrated in any application which company, customer, shop, whatever has. Then core is basically the application where we also store the embeddings. So basically, this is the part where the magic happens. We take the data in various data formats, we clean them, parse them, and prepare them for embedding, embed them, store them in vector database. There we are keeping them on basically your hardware. You are not sharing it yet fully with the model, only during the embedding one. And then user starts typing, which is basically generating something like a in human language question in our terminology query. And then we are doing there a lot of prompt engineering to understand what is the meaning or intent behind the query. We are searching the data in that local storage, which are really relevant for that part. And Filip will tell you in next slides a little bit more, like actually how we are actually putting the data into this vector database. During the query, we really try to understand the intent. We search that one locally, and we are doing there a lot of prompt engineering to really specify and prepare the correct prompt to ask the large language model. We were experimenting with several of them. We tried also the Slovak one, the BERT. Slovak BERT, yes. But and what we did is kind of actually independent on the one which we use. Like we can switch the LLM model in the future. It depends on their development. But the best results so far we received with ChatGPT. And right now 4.0. When you are interacting on the web, you might not as a user see the differences, but when you are enriching the data, the way how is it formatting the responses and how is it understand the context is significantly better. But we can touch it separately if we want. So right now we use 4, but we experimented also with various ranges of different models. So let's now deep dive a little bit into that process. So Filip, please.
Sure. So very briefly, the process of embedding is a process of representing the knowledge base. So I got the data, and I somehow need to, I wouldn't say teach. It's not machine learning as per se, but I somehow need to get the data to a shape I can later use to gather the knowledge from. So as I said, it's data preparation as the first one, it's vector embedding as the second one, and it's vector storage, vector database, or vector library as the last one. Diving just a bit deeper on that, so data preparation is about reading the data from the input file, which is obvious, or a website. It's cleaning the data and parsing the data to computer-readable format. Might sound straightforward, but this is sometimes the trickiest part of it all, because the data can be really ambiguous. And some of the challenges, like this one, you have a very nice table. It looks great in a PDF. You can read the information straight away, no issues. But once you just read it via PyMu PDF or a different library, this is what you will get. So there is a lot of strange signs, and it might not be that bad, right? You can clean it easily. But what you will get next, after some basic cleaning, is this. And you already got the table structure broken, and you can't reconstruct the table back. Maybe you could, because you can say, okay, every second line is the item on the right. But in a case like the sentence right in the middle on the left that consists of 2 lines, if this is a PDF, it is already broken. So you can't really rely on reconstructing the table back. So PDF is not the nicest format to read tables from.
Yes, because you would like to also remember what is Satzba, like really what is the name of that column, because it's important. And also second axis is important to have actually this information tracked.
Yeah, because tables basically it's a value that has 2 or more keys. One key is on the diagonal, another key is on the vertical, and that's what you have to do. Or you can even have more keys, like
yes.
So the tables definitely are tricky. And our next question, and the last question from this part is, how would you parse this table? I'm not sure. We can write it down. Maybe somebody brave.
If you can speak up, or won't speak up. What would you do with this table? Yes.
Both answers are quite good, I would say.
Yes, because with OCR, some of those libraries can actually reconstruct the table. So that's correct approach.
Especially AWS Extract is great.
Yes, but the best one is just, I will see what somebody wrote. Yep, Amazon actually is what do you just mentioned, Filip?
Awesome.
Parse to latex.
Is it doing speech-to-text recognition or something?
Yes. Azure Form Recognizer, yes. Or the cheapest one actually asks for Excel file. And then when you can export the Excel and you already have the key and structures, and it's much more simpler. But in case you don't have this source Excel file, then Amazon is a good direction, or also the Vision, which was mentioned.
Okay, moving up, vector embeddings. So as I said, each section of text is assigned an n-dimensional vector. In case of our GPT, we use text embedding ADA 002, and that's a vector of 1,536 values. So it's a large vector that can represent a lot of knowledge. This is how it might look in our embedding JSON file. So you have a text. If you see the the code part of it. So you have the text, product trade, conditions for credit cards and authorized overdrafts, and you have the embedding, just part of the embedding. This is nine numbers out of the whole vector. So this is how each information is represented under the hood. Next one is the vector storage. So you need to store it somewhere, and not only that, because you can store it in any sort of database, such a vector, but you need to be able to search for your most likely option. So here I'm mentioning a couple of vector databases like Chroma, Pinecone, VV8. Even Elasticsearch has a very nice support for it, and in fact that's what we are using in many cases. And what the main thing here is this vector database has to be efficient at finding the closest vector to one in the query. So, and it's used for semantic search again. So that's what we are looking for, and that's what these tools can bring to the table. So that's for the first part, which is the embedding process. So this is our preparation of the knowledge, and next part is the chat process. So the live, the prediction part. The inference, if I take it to the machine learning world. Again, very brief intro. Query formation is the first one, so it's a lot of prompt engineering. We actually use GPT to format a query for GPT, and that brings a lot of value to us. So that's what we do as a first step. Then there is the vector search, already mentioned in the database part, and the answer generation, for which we also use GPT. Query formation, very simply, user question is the input. You have to remember the history of the conversation. That's what we do. So if I show a brief example, it's not so greatly visible, but on the left side, I'm asking what are the limits on some type of a card A, card type A, and I get a quite a specific answer about the numbers. And on the next one, I'm asking, how about card type B? And I get a very specific answer about card type B. While in this case, I'm directly asking, what about card type B? But there is no history previously. So I get a very generic and a very generic definition of what card type B is, but obviously I'm not getting any information about the limits. So what I'm trying to say is we remember the history of the conversation, and we prompt our next query based on the history connected to the most recent question.
Yes, so we would like to have like your checked interface effective. It's not only about I just take the question which I received and forward it further to the large language model. It's actually good to do that prompt type of engineering to look on what happened before, what was the conversation. We can even look what was the user who is speaking, and based on that you can get more precise answers because it matters for the results.
Okay, moving up is a similarity search. What we do, we take our new query and we assign it a vector value, obviously, so we can compare it to the vector values that we already gathered in the embedding process. So for that, there are a couple of algorithms out there. You can use KNN, which is K nearest neighbors, approximate nearest neighbors, or FAYSS, which is Facebook AI similarity search. It's getting very popular. It's a nice algorithm too. Or you can just search in a tree. And the last one, answer generation. So the goal is to form a correct and a good-looking answer too. Both of these aspects are important because you want it to be factually correct, but you also want it to look good because maybe you're going to present it to a customer. So what we do, we gather the facts from the conversation, and we gather our output from the vector search, which I mentioned in the previous step. And we ask GPT, based on all the conversation that happened up to this point, to generate a proper answer.
Yes, so up to this point, everything was happening on our application, on our local servers, also with embedding, with similarity search, with query formation, etc. And basically what we use language model for, in this case the ChatGPT, is that formulating the response in a way that it understands the questions, context, and it formulate the raw data, which are from your process or anything, and put them in correct language. It doesn't matter whether it's English or Slovak or Japanese, but basically it's the one who will translate that information which is yours into the readable format. So it seems like I'm responding to you.
Yes.
And here is the difference what I mentioned, like when we did it with the chat GPT 3.5 and 4.0, there is significant better improvements in the formulating of the sentences and how natural it looks like to that end client. That basically you can see the difference that it's much more human-centric with that 4.0 like it was with the previous models.
So both are factually correct.
Yes.
The GPT model is not deciding the factuality of the answer, but it just looks much better.
Yeah, like
it can make a difference.
The factuality is basically happening in the similarity search, what was mentioned by Filip, all on the application. So basically we have under control what will chat reply to you. So basically it's not some advanced, we are not even using the knowledge base of the large language model or anything to generate the context of the response. That's part what we do. We prepare what is actually the data response or the correctness or the source of the response, and the large language model is only used to format it in a human way so it fits into the conversation. I hope it was not too complicated explanation.
We'll see.
Okay, we'll see in questions.
So before that, just last one slide. It's about the evaluation. I think this is maybe when data processing is like 60% of the work of a data scientist, evaluation is like 30% of the work. I'm pretty sure of that in most cases, because what is in the middle is almost always given. And you can just take the state-of-the-art models and do your thing. And evaluation, how do we know it works? That's the main question. And you need two things. You need the metric. Ideally, you can select it in the beginning, so you're not bending your approach to the metric, but the other way around. So you first want to have the metric and then fit the metric as good as possible. The metric can be like factuality of the information. So just if it is card limits, it can just be the numbers. So it's 5,000 for daily usage, is 20,000 for monthly usage, and so on. So you can measure that. Another thing, you can use some NLP metrics that decide the similarity of text, like blue score, for example. And you can directly use a cosine similarity of two vectors. So how far really those informations, as we've seen before about the dog and the boy walking, are from each other. And you can decide the quality of your answer based on that. And important also definitely is the data set. You need to have a statistically significant sample, and that's a nice terminology, right? But there has to be some randomness to it. There has to be some heterogeneity to the data you have in that set. I'm just adding up to it, but that's what you need. And you can definitely use GPT to generate the data set. That's what we are doing in most cases. It saves us a lot of time, and then we just correct what was generated as the answer and as the question, and also as the answer. But it saves, let's say, 90% of the time.
Just to give you an example, basically, we use ChatGPT and the data to generate questions, like what would you ask as a human? And then we need somebody who we call domain expert, but it can be owner of the shop or somebody who knows the process, what we are training of. We show them this data set of 1,000 questions, and they will check it. They will read the question, and they will see or think, what is the ideal answer I would like to see? So he can even adjust it or type there, this is the ideal answer I want to get to this question. And this is our the initial metric. Then basically what we do, and what you should do also when you are training your own data, on the beginning, you basically give these questions to your chat. You get the responses, and then you do the comparison what was actually said and explained before by Filip. You compare how it was similar to the response in words. Like basically, if the chat told what you wanted to hear in the word meaning of the words. And second is to check the factuality. So basically, if your limit or your product cost 50 euro, if it really stated 50 euro and not as we saw it here, 108% together. So basically we are checking the number correctness and the factual correctness. And on the end you get a score. Doesn't matter, it can be 80% or 90%. But important is that as you start to play with it, play with the way how you formulate the query, how you embed the data, how you clean your data set, you should see with this evaluation set that you are increasing the quality. Basically, it's giving you the more precise answers to something what you actually expected to receive. And it's important to measure it because during the fine-tuning process, you can make mistake and actually you will get worse quality than you were expecting. That's also part of the process. So it's really important to have the evaluation so you can measure it at least somehow independently. How good are you and or not? Basically, we are improving or actually decreasing the performance of your chat. So that's a really important one. It's good to start with it. So really, as soon as you have your first version, you should have also the evaluation so we can see whether you are really the changes what you are applying are helping or not helping to improve your product. And this is the last slide, I believe.
Yeah.
Yes, so we were talking a lot, but we would like to really see how it works. There is not only the theory, just stop by at our stand and you can try it by yourself. We have like 4 demos ready, so we can see really how is actually the solution performing.
Yeah, our booth is at the closest one to the registration tent actually. It's in the block A on the right side. And you can see demos from banking sector, from telco sector and from eShop sector.
Thank you very much. That was Jaroslav Vojcik and Filip Stano. And let's take a look at your questions really fast. How many messages in chat history you again feed back to the AI API?
Right now, actually all, no? In that one thread, what we have.
Should they sure again feedback?
Like when you start chatting.
He's counting in his...
Yeah, there is definitely a limit to it. I'm just thinking why the question is there.
Okay. Why did you put it there?
Yeah. That's not what I thought, yeah.
Okay.
But it's limited per the conversation, like what you have. So it's not being passed from one conversation to
I'm
another.
trying to understand the context behind the question because there is a limit.
The name of the questionnaire is chatbot, so...
Oh, absolutely.
Take that into...
Yeah, definitely. So I'm not gonna...
The equation that it's probably generated some...
Should I answer the computer or if it is...
Yes, just let computer answer the computer.
Yeah.
Okay.
Sure.
Okay, what can I do during the vector embedding process to make sure I get clear references of source documents with the chat response? Okay. This is my limit, so we just touched it and...
So, yes, basically what we do with every embedding, we also keep track from which document or page or anything it came. And when we are actually printing the response, you will see it on the demo. We formulate the response and on the bottom, we always take the sources from which we took the data for the response. So basically, we are transparent about from where we generated the data, and it's important. Like if you have, for example, complex process or your product even, you have the question was about the shoes. So basically, we took the source data from the description on the eShop with the shoe. So we put there the link to that exact shoe, and if you would like to see the more details, you can just click on it and you see the whole. And we are even thinking when it's a document that we can highlight the section of the document from where we took that source data. And it's important because the language model can change slightly the formation of the text. So if you need to know exactly the original, it can be LOL, for example, then you can still open it and see it in the source. So that's the...
Yeah, but good thing to start with is a tree, where your first layer, first set of nodes is just the documents, another set of nodes is the paragraph. Then you can traverse the tree, and on each node of the tree, you can have the information of the source of the previous node.
But we are tracking it because it's also important because some documents, so if you're working with banks, they can have different confidentiality. Like you can see it, I cannot see it, he can, so that can be pretty complex. So we also have to keep track of what is the confidentiality of the data. And then based on the user, we use only that data which you can see. So it's a good question.
Thank you. I really love it how you make eye contact with me. I pretend that I understand. I feel like a neural network model 10 years ago. I understood each of the words you are telling me, but I don't understand the overall sentence. So this is AI 10 years ago. That's how I feel right now. What do you do if the message that you are trying to send to ChatGPT is too long in case of a lot of additional data? I would cut it into 3 messages.
Absolutely.
Okay. Ask me anything. I'm here for you. Okay, how expensive is a private instance of ChatGPT? I just paid for it $20 a month. So how much is it?
It's based on the usage. So basically, they are charging you based on the amount of words, which they call tokens, you send. And they have 2 types of prices for the question. Like that's the input, which you send to ChatGPT. It's cheaper. And then you have a second price for the response, like what they generate and formulate. And basically, the price is approximately 3 cents for 800 words. So like that. And to that previous one, if somebody who put it would be interested to know more, just stop by, because that's the prompt engineering and query generation, what we do there. And we are actually in control how big is the embedding and how big is the context. So we are limiting it in a way that it's still okay for the ChatGPT. So basically, in our application, we make sure it's not exceed the part.
Okay, we have 30 seconds until the end. So I would like to thank Jaroslav, Vojcik, and Filip Stano again.
Thank you. Thank you.